Hi class, today we're going to look at Chapter 5, Lesson 5, Proportional and Non-Proportional Relationships. What we will learn. We will learn first how to identify proportional and non-proportional relationships in tables. And then, of course, we will also learn how to describe a proportional relationship using an equation. So now there are two quantities that are proportional if they have a constant ratio or rate. For example, if I look at my 1 to 300, I have to make sure that each one of my ratios, or rates in this case, reduces down to 1 over 300. So when I divide by 2, I get 1 over 300, and then 3 over 900 also reduces to 1 over 300. And then finally, I have 4 over 1200, and that reduces to 1 over 300. So yes, it is consistent, so this is proportional. Now, if they do not have the same ratio or rate, they are said to be non-proportional. So in this case, if I have for every $2, it is one sock or a number of socks, so like one pair of socks, I need to make sure that it is consistent for all. So $4 to 2, that does reduce to 2 over 1. Then 6 over 3, that also reduces to 2 over 1. And finally, as I look over 6 to 4, that simplifies down to $3 to 2. So it actually doesn't simplify all the way like the other three answers that are 1 to 2. So this is the reason why it is non-proportional, because it just takes one to be inconsistent. Go ahead and turn your notes over to the backside now. Now we're going to determine whether each table represents a proportional or non-proportional relationship, explaining your answer in complete sentences. So as you can tell, we have 1 to 100, which is our consistent, and that's our constant that we would want. So we're going to take the 3 out of 300, and we're going to simplify that fraction to see if we also get the 1 over 100, which we do. And then we take the 5 over 550, and when we reduce that, we end up with 1 over 110. So already we do not have any consistency because of the 1 over 110. And finally, we know that 6 out of 600, that also would simplify to 1 over 100. So we do have 3 that are consistent, but because 1 is not, we consider this non-proportional. So our answer in this case is no, non-proportional, because there is no constant. There's no consistency. One of the values changes from 1 over 100 to 1 over 110. Now, in example 2, we know that we have cups of flour that are 2, 4, 8, and 10, and then the loaves of bread are 1, 2, 4, and 5. So in this case, we know that we have our x values on top and our y values on the bottom. So in this case, we can write it as 2 over 1 for the cups of flour to the loaves of bread, and then we have 4 over 2. And we notice that that can be simplified by 2, and that also gives us a 2 to 1 ratio as well. And then 8 over 4, that gives us a 2-to-1 ratio because we divide this by 4. And finally, we have the 10/5, and that reduces down to 2/1 ratio because we can divide by 5. So proportional relationships can be described using equations of the form y equals kx. So in this case, this is proportional, and the reason for that is that our ratios are consistent. Alright, so as I was saying earlier, proportional relationships can be described using equations of the form y equals kx, where k is the constant ratio. So in other words, k represents the ratio that each one of our ratios reduces down to. The constant ratio is the constant of proportionality, also known as So the constant ratio is the constant of proportionality, or it's also known as the slope. So for example, the cost of 2.5 pounds of meat is $7.20. Find the constant proportionality. So when in this case, we are simply taking the $7.20 and we are going to divide it by 2.5. So as you can tell, we're dealing with money, so we can even talk about the constant proportionality being unit rate, and meaning that we would get a denominator of 1. So in this case, we can take the 2.5 and we can change that to 2.5. So we can just go 720 divided by 2.5, or 250 if you want to look at it like that. So we divide 720 divided by 2.5. and we end up with 2.88, which would be out of 1. So it'd be $2.88 out of 1 pound. And that would be considered our constant of proportionality, which in this case it's a unit rate because it's out of 1. Now we're going to write an equation relating to the cost of pounds. How much will 4 pounds cost? So if we have a constant of $2.88 over 1 pound, then we know that's the constant. So this is known as K. So I have y equals kx, and the x represents the different pounds that I can substitute in anytime that I need to. So I know that my equation would be y equals $2.88 x. So in this case, I want to find out how much it would cost for 4 pounds. So x actually is 4 pounds, and I substitute the 4 in for this equation. So I have the 288, and I'm going to times it by 4. And it ends up being $11.52. So for 4 pounds, it's $11.52. But in order to figure that out, I could just create an equation by using the constant rate that I had found in the previous question. Now go ahead and complete questions 5 and 6 like we did in the previous sections.